Yeah, so have you looked in Can Mamba Learn How to Learn paper?
No, I've just seen it now.
Okay.
Yeah. That's something. Where is it? All right. First step, make a repo. What's this model called? Do you have a name for this?
Mamba Former. Like not Mamba Transformer, but Mamba Former.
Mamba Former?
Yes.
Is that what they call it?
Yeah. This is for the.
Yeah. Okay. Yeah. Okay. All right. Let's fucking make this then. Gonna make the GitHub first. Set the time. I've been on a flight for like a long time. I was traveling. I just got my mouse. Dude, having a mouse is amazing. I don't think you understand.
Yeah.
This is like having a mouse is just amazing. All right, so we're gonna make the repo. Get inside the repo now. All right, so how does this thing work? That's old. This is interesting. All right, so we're gonna make this one. Okay.
Okay. Yeah.
Okay. All right. Actually, no, it's not the right GitHub. Okay, there you are. This shouldn't take too long. Hang up some stuff here. I don't know what to do. feel the lag. So much lag. That or I'm not the computer. I'm gonna wait for like 40 hours. Yeah, this is very slow. Okay. So, gotta make a module here, initialize some stuff. Like, let's see what else. Initialize some stuff. What else? Oh yeah, something. I don't know why they're using multi-head attention. Multi-head attention sucks, so we're just gonna go with the next best thing, which is multi-query attention. If you see anybody using multi-query attention, like self-attention, dude, that shit is old, man. Not good. So we need to initialize the input Mamba block, which is gonna take in just so that's gonna take in that'll happen once. Pass in with these states. We don't need to do anything with that. Decount. Okay, that's good. Multi-query attention. Okay. So this is what we do. Yeah, this is bad practice. You see, don't ever do this. This is supposed to be the same thing as stem, but much simpler. Simple. Put the heads. Don't forget to create positional arguments.
So what's the actual difference between the multi-query and the multi-head attention?
So it's faster. It's much better for reason. There's multiple queries for multi-query attention, whereas in multi-head attention, there's a good diagram that illustrates this by Google. Here, let me show you. So this is what it looks like. Is basically all of them. Like, there's a bunch of values, keys, and they all like. Do you see this?
Yeah, I see it.
Okay. Yeah, so there's many values, many keys. There's like proportional amount of queries with keys and values, and then grouped query is even better than multi-query. I'm just using multi-query here because it's simple. But multi-queries, you have a bunch of queries that map to one key and value. So this is obviously much faster than this.
Yeah. Cool.
Does that make sense?
Okay. Yeah.
Okay. Cool. All right. What are you doing? Oh yeah. Okay. So to make a thing in PyTorch, you gotta put your photo path. Wow. So first step is function, but we're going to do skip. So we have a skip there. So the attention is going to output a bunch of stuff, but we really just want to get one thing. So we're going to map that to a function. Then add residual.
So the X is the input tensor.
Yeah, so we're gonna add. We're implementing this right here. Now we're gonna add Mamba. Now we're gonna take we're gonna create a script too. And then we're gonna add residual and return. So return x plus 6. And that's pretty much it. But it goes deeper there. It's not this simple. So now we need to make the actual model. We're just implementing this right here. Copy these. We're gonna copy this. But we're gonna add a couple things. We're gonna add the number of tokens, which is the vocabulary of the tokenizer. And we're also gonna add depth, which is depth is the number of blocks. So when you use a language model, you need to give it. There's a limit. It can't process every token in existence. So the tokenizer will usually have a limit of around 30 to like 300,000 different tokens. And what we're going to do is we're going to embed those tokens, and we're going to transform them from tokens into embeddings. And so we do this by calling this function or class, whatever it is, and laying out the number of tokens. And we're going to map that to the dimension in tensor space. Now we're also going to have another Mamba as inputs. So this could be input Mamba. We'll just do that. And then layers of Mamba former block. So here we need to call the list, which is going to hold. This is going to hold all of the layers. So we're going to create this. We're going to lay out all the parameters. And then we are going to specify for a range, which is the depth. So for every, like if we put the depth to 10, there'll be 10 iterations of these things, of this block, which is the output. And so now what we're going to do is we're going to take a tensor. Actually, no, it's not going to be a tensor. It's going to be a token. Just random images. So we're going to embed the tokens. So after that, then skip. So we're going to create skip, save that for later. Then we're going to have a Mamba, which is input Mamba applied to X plus the skip. And then this will be sent as an input into the Mamba former blocks. So for every layer in self layers, we're going to apply the layer, and we're going to also add a residual, and then we're just going to return that. So there's a couple of things, cool tricks you can do here to make this actually train. So we're going to normalize this. Every time after you embed, it's mostly like common practice to normalize. So you could normalize that. So here I'm defining the class inside of the forward, but usually you could also do this. So you could do something like this, and then you would just you could do something like that. It looks cleaner, but sometimes you can do it. Yeah. So this is basically almost finished, but not really. There's a couple things we're missing. So we need to get the output tokens from this. So this right here is going to output beddings. So this right here is going to output embedded. This right here is embedded. This is not a token. A token is integers adding up to 1. So if we're predicting the possibility of these tokens, we need to apply an output head, which is 3 things. It's a layer norm, a linear, and a softmax. And so by doing this, we can get the actual output token. So yeah, let's make this optional if we want. Yeah, so here you go. Something like that. We can simplify this even more. But yeah. So now if we try this, we're going to make a random sender, see if the forward pass works. So remember we need to. So this is a token. So now we need to set up the model. So we're just going to set a bunch of stuff. These are like parameters head to the we're going to run a forward path, which means we're going to run a loop, and we're going to print. Now we're going to run this. And while that takes some time, I'm going to change this on. So that's pretty much it. Now all you would have to do is, I'm also going to go over this. But basically after this, it's pretty much you get a data set, you convert that data set into tokens, and then you pass this in, you run a forward pass, and then you run a backward pass, and then you train them all.
That sounds like back propagation.
Huh?
It's like the back pass. Is it like similar to the back propagation?
Yeah, so the forward pass is a forward pass. It's not actually like you need a loss. You need to tell the model like you're wrong. You did this wrong. Now there's no feedback mechanism. It's not learning. It's just running an import that tweaks the model. It's just running something in the model. It's not learning anything. You need backprops for that. But I made a GPT just to help create training scripts. Because man, it takes a long fucking time. We did this pretty quickly, but like creating data sets takes so much time, man. It's not even funny. So let's see if there's any error with this. And then we could try to train it on something simple. You also need a tokenizer for this. So you need a tokenizer. Send it. I like Token Monster a lot. Token Monster is my favorite. It's super funny. It's like a really compact, small tokenizer. But the models like GPT-4 use tick token. Sounds like talk.
Yeah.
So this is what no, this isn't
But with the Transformers library, can't you just get the tokenizer like the Llama 2 line?
Yeah, you could do that. But then you're still limited by the same Llama 2. So, like, how big is the vocabulary is important because. Does that make sense?
Yeah, God. So
the vocabulary size is how many potential symbols you can learn. So I think Llama is 30,000 or something, which isn't a lot.
Okay.
So this is still running. This should work on your computer or Mac. I don't even have a GPU, so.
Yeah, I have an AMD machine, so it's not really working either. But I can rent like GPUs in the cloud. If we want to train something right now, we can do it like I think I have shape home credits